Lithium-ion batteries are the front runners in battery technology. They have the highest energy-to-weight ratio of any battery on the market and are reliable and durable. The most common applications of these batteries are in electric or hybrid electric automobiles, personal devices, and power tools. This broad scope of usages, and subsequently consumers, makes the information garnered from this study important and practical. It is generally recognized in the battery field that when the load is removed from the circuit, the battery voltage gradually recovers or rebounds. The purpose of this experiment was to test whether or not this voltage rebound affects the discharge duration of the battery. In order to set up the experiment, I soldered together 3 1-ohm resistors in series to make a total resistance of 3 ohms. I then attached a single battery holder to the resistors to make a closed circuit. Lastly, I attached the voltmeter to measure the voltage of the battery. In order to begin the experiment, I placed battery A into the battery holder and started the timer. For the first trial, the battery was allowed to discharge without any circuit disconnection, while the voltage was being recorded every minute. Once the battery reached a voltage of 0.2 volts, it was disconnected from the circuit. For the second trial, after 4 minutes of discharge, the battery was disconnected from the circuit. After a disconnection period of 2 minutes, the battery was reconnected to the circuit. This process was repeated until the battery reached a voltage of 0.2 volts. The voltage was recorded every minute of discharge and after each disconnection period. For the third trial, after 4 minutes of discharge, the battery was disconnected from the circuit. After a disconnection period of 5 minutes, the battery was reconnected to the circuit. This process was repeated until the battery reached a voltage of 0.2 volts. The voltage was recorded every minute of discharge and after each disconnection period. This order of trials was repeated for batteries B, C, and D. Additionally, at the end of every trial, the batteries were recharged using a Team 10Energy 50-watt balancing charger. And now for the results. As you can see from the graphs, the voltage rebound was accurately created using these circuit disconnection patterns. However, there is little consistency in the discharge curves between the graphs. The results of an ANOVA test confirm this observation because no significant correlation was found. Because no significant correlation could be derived from the data, by this experiment we can conclude that the circuit disconnection does not play a role in the overall time it takes to discharge lithium iron phosphate batteries. Again, I'm Will Elkins, and thanks for watching.